So hello everybody, thank you for being there this morning. So my name is Yannick, I'm located in France and I'm part of the engineering branch of Air Liquide. And today I'm glad to introduce the TurboBrayton as a disruptive technology for the biogas liquefaction. So first of all, we have to say that this technology has been certified by Solar Impulse. And the Solar Impulse is a prestigious label aiming to certify the technologies on two criteria. First one is the profitability, or let's say the affordable and bankable technology. And second criteria are technology good for the environment. So we are very proud of this recognition. So on this picture here, you can see on the right side of the screen, you have the leach scoping plant that was started up in 2010. So the plant is running for 10 years now, and it is owned and operated by Air Liquide. It produces 14 tons per day of liquid biomethane. Yes, we can say that the technology is there. We did not face any major incident in 10 years of operation. So yes, technology is there, it runs, and it is affordable. So when we look at this business, we have the sources of gas, and then we have the technology, and we have the market. So each gas is characterized by the pollutant, and it requires a specific pretreatment in order to make sure that it can be liquefied. So if we review the various available sources, we first have the biogas coming from an anaerobic digestion process. So the biogas is featured with a content of CO2 plus sulfur. We have the landfill gas. So landfill gas is the same as biogas plus nitrogen and oxygen. And then we have the pipeline gas, which is mainly methane plus AVs, hydrocarbons, and potentially also THE, which is the odorization molecules. And then we have the flare gases and also the boil-off gases from the terminal gate. Those two gases are very close from the pipeline gas. So then we have the technology with the various pretreatment systems enabling the pretreatment prior to liquefaction. And the core of the technology is obviously the TurboBrayton for liquefying those gases. And then we provide also a series of, let's say, downstream equipment such as storages and distribution equipment. And then when we look at the market, we see that the market is mainly composed from the HGV or the HGV-AV GOAT vehicles fueled with LNG or bio-LNG. You can see here the cryogenic tanks on board of the trucks. So this is definitely the first market. The second market is the maritime industry. We see now more and more ferries in Scandinavia, for example, fueled with a mixture of bio-LNG and LNG. And then we have the industry with more and more plants switching from propane, for example, or diesel to bio-LNG. This is the case in Scandinavia also. And last but not least, we have the automotive market with the off-grid station where the molecule is stored in liquid state, so bio-LNG, and then it is compressed and vaporized to fuel the cars. Okay, so at Air Liquide, we provide a larger range of liquefaction product, and we cover the entire, let's say, demand of the market from very small scale, lower than 8 tons per day, up to a very large scale, more than 2,000 tons per day of liquefied gas. And in the middle, we have the so-called TurboBrayton that is covering a range from 10 to, let's say, 50, 100 tons per day of bio-LNG. So I will review step by step all of those different technologies. So if we go on the very small scale, so as I said, lower than 8 tons per day, so 40 gigawatt hour per year of bio-LNG, we provide a fully integrated solution that includes the biogas upgrading, the CO2 polishing to polish the gas down to 50 ppm CO2 before entering on the cold box here. And this cold box is called lean to LNG because it uses liquid nitrogen as a cold media. So the liquid nitrogen is sent into the heat exchanger, it is vaporized, and then it cools down the methane, which is liquefied. So the liquefied methane is stored on the tank. And then we also supply the truck filling station for the truck loading station for exporting the bio-LNG. So the smart thing on this solution is the fact that the liquid nitrogen is first used to cool down the methane, and then the vapors are used to regenerate the adsorption unit, which is here. Okay, the second one is this one is a medium scale, which is so this is a plant installed in Finland, in Topinoja waste plant in Turku. So this plant liquefies 10 tons per day of biomethane or biogas, representing 50 gigawatt hour per year. So as you can see here, we provided the entire EPC contract for the plant. So the biogas is first upgraded with our membranes technologies. And then this biomethane goes to the CO2 polishing, then to the liquefier, and it is stored into the tank. So this plant is running for several months now, and it produces again 10 tons per day. So you can see a more accurate view of the various components of this plant. So we recognize here the biogas upgrading unit. So you have the charcoal for removing the H2S, the biogas compressor, the membrane system, the dryer. Then we have the CO2 polishing. Then we see the TurboBrayton, the TBL 350, and then the tank and the tripoding stations. Another plant is the one which is that will be soon installed in Stora Enso's Nymölla paper mill in Sweden. So this plant is using the TBL, the TurboBrayton liquefier 525, allowing a production rate of 20 tons per day. We also have the TBL 700, allowing 25 tons per day liquefaction rate, so equivalent of 30 gigawatt hour per year. So you see that the machine is now completed, and the on-site work is ongoing in Sweden, and the plant will be in operation in early 2021. So you can see the liquefier, the TurboBrayton 525 here. The picture was done 2 weeks ago at the exit of our workshop in France. You recognize the mountain here in Grenoble. And yes, you can see how the plant is easy to handle, and to operate. And it's really a compact solution, skid mounted, ready to start. So now, and the last one, which is the largest one, which is not yet available for the market, but will be available in mid-2021, will be the 50 tons per day. And in the future, we foresee a 100 tons per day for this market. So as a reminder, you have the entire range of TurboBrayton liquefiers. So from 10 tons per day up to 100 tons per day liquefaction rate. Again, the technology is really compact, very low footprint, high efficient, and reliable, because we are using a turbo machine using a magnetic bearing, so no contact between the rotating parts of the system, so contact-free technology. Okay, so as a reminder, or as a summary, we can summarize here all the key benefits of this technology. The TurboBrayton again. So number one, it's a maintenance-free technology. So 5 years maintenance-free. So those machines are installed on board of LNG carriers, for example, sailing over the ocean. So it's pretty clear that we cannot do any kind of maintenance during the course of those vessels. Number two, it's an efficient solution with a low electrical demand and high efficiency, thanks to the turbo machine and thanks to the TurboBrayton cycle. It can be operated at partial load from 0 to 100% of the load. So big flexibility in terms of operation. So accommodating to fluctuation of the biogas flow. Number three, it's a safe technology. So there is no hydrocarbons. There is no risk of leakage. The cycle gas is a mixture of helium and nitrogen, so it's an inert process gas, so no risk, again, of explosion. Number four is easy to operate, as you have seen on the different plant in operation. It's a plug and play, so it's very compact, so it's a very stop and go. It is designed for being unmanned, and it is fully automatic. And number five, installation is quite simple due to the plug and play design. So compact and plug and play design, easy to install and operate. Number 6, it's a refrigerator, so there is no limit of low temperature, so meaning that we can easily accommodate the boil of gases or the flash gas thanks to the methane subcooling option of the plant. And number 7, it's utility free. We just need electricity, nothing else. So easy again. And number 8, it's flexible in the sense that the cold power is instantaneously available. So we can have a stop and go operation, or let's say a fluctuation on the load. It doesn't matter. The plant will respond instantaneously. Okay, so in addition of those of this TurboBrayton technology, we have developed a series of ancillary equipment that can be installed together with the liquefier. So we have the upstream pre-treatment system. So as we said, we have the biogas upgrading system using membrane. We have the CO2 polishing using adsorption process. We can also provide a amine scrubber for natural gas cleaning, for example. And downstream the liquefier, we supply cryogenic tanks of various size that can be adjusted to the liquefaction rate. And we also provide in-house truck loading equipment to export the production of LPG towards the filling stations or the end users. So in terms of experience and references, here we show the last references. So the last one is a 24 tons per day plant that is currently in manufacturing phase that will be installed in Norway. The project is called Griver LPG in Norway. So we provide the full EPC for the methane polishing and liquefaction, and the plant will be started up by the end of 2021. This one is the Nimola in Sweden. We already spoke about this. So it will produce 20 tons per day on the paper mill, and the startup is expected soon in early 2021 or so. This one is the Turku that we mentioned also in the presentation. So the plant is running for several months now. So and it produces 10 tons per day. So this one is the Lidköping one in Sweden. So producing 14 tons per day. Again, running for 10 years now with no major incident. This one will be delivered in Korea for methane bench test. So it is TBL 350, so producing 10 tons per day of liquefied methane. And this one is what we call the lean to LNG, so using liquid nitrogen. So this plant is running in Italy, and it produces 8 tons per day of methane. So yes, this is the end. This is all for today. Thank you very much for your attention.
That's great. Thank you very much, Yannick. That's it's really fascinating. So we'll go